Welcome to aminacademy.com. In physics, let us discuss about gravitation. Gravitation or gravity is a force that exists among all material objects in the universe. For any two objects or particles having non-zero mass, the force of gravity tends to attract them towards each other. Gravity operates on objects of all sizes, from subatomic particles to cluster of galaxies. In our universe, each and everything attract each other with their own force. That is a gravity. Suppose I attract you, you attract me, and I am attracted by others. That means each and everything solid body is attracted each other. That means complete the universe, each and every materials is attracted to each other is by using a gravity force, but it is a very less force compared to the other forces, so we cannot imagine the forces easily. We know that everybody knows that a falling apple, why that apple fall from the tree, that Isaac Newton realized that some force is attracting the apple towards the earth. That means from that initiative he decided something force is attracting each other. This is called gravitational force. Further detail you will do. Each body in this universe attracts other bodies towards itself with a force known as gravitational force. Thus, gravitation is a study of the interaction between two masses. Out of these two masses, the heavier one is called a source mass and the lighter one is called a test mass. Here, we are on this earth, is attracted by the earth. The heavier one is of course this earth is a source mass, and lighter one is called test mass. We are a test masses. That is why earth is attract all the things towards its center. That means that source mass is heavier, so we feel that is we are attracted towards the earth. Even we attract the earth, but it is we are very less mass than that comparing to the earth mass, so we don't feel we are attracting the earth, but earth is attracting you. We can easily imagine. That means even the earth is revolving fast, we are not thrown away because we are attracted towards the earth safely, so we are in this way. Otherwise, if there is, imagine if there is no gravitational force, we already thrown away. That means we cannot live in this earth. A gravitational force is a central force which depends only on the position of the test mass from the source mass and always acts along the line joining the center of the two bodies. That means we are attracted towards the earth, towards its center. Newton's law of gravitation. According to Newton's law of gravitation, we can define this: every particle in the universe attracts every other particles with a force whose magnitude is directly proportional to the product of their masses. Suppose the mass m1 and m2, the product is m1 into m2, which is directly proportional to the gravitational, that is force, gravitational force, and inversely proportional to the square of the distance between their centers. That means suppose two masses is far away and this attractional force is less because it is far, because it's a distance square, it's inversely proportional to the distance square of the distance. And if the masses are heavier, the force is heavier because it's directly proportional to the product of their masses. On combining these equations, here one is F is directly proportional to the m1 and m2, and F is directly proportional to 1 by r square. Combining both, we have F is directly proportional to m1 into m2 over r squared. Further, we can the direct proportion is balanced by a constant. It's called a universal gravitational constant G, capital G. So we can use a formula F equal G into m1 into m2 over r square. This is a gravitational force law formula for gravitational force of any two bodies, between any two bodies. Here we can decide this dimension formula of G is m in a multi-system, that is m minus 1 L cube t power minus 2. We can derive this MLT from this formula by using other units, that is F and m1, m2 and r squared. Also, value of the gravitational constant in SI units is 6.67 into 10 raised to minus 11 Newton meter square kg minus 2. In CGS system of units, that is equal 6.67 into 10 raised to minus 8 dyne centimeter square gram per minus 2. Now look at this. Here we can understand this gravitational force, Newton's law of gravitation, by using this figure. Here this heavier mass m1 and m2 is smaller mass. Here this both is attracted each other, that is both force is equal, F1 and F2. Here this F1 is equal to F2 is equal to G m1 into m2 divided by r square. This r is the distance between the centers of these two masses. Principle of superposition of a gravitational forces. Newton's law of gravitation answers only the interaction between two particles. If the system contains n particles, there are, that is n into n minus 1 by 2 such interactions. Here suppose, look at here three masses. Three masses are here. 3 mass means how many interaction is there? N is 3, n minus 1, that is n 3, n minus 1 is 2 divided by 2 equal to totally 3 interactions. Like that we can find how many interaction of such number of particles we can find by using n into n minus 1 by 2 such interactions. According to the principle of superposition, if each of these interactions acts independently and uninfluenced by the other bodies, the result can be expressed as the vector summation of this interaction. That is, F is F12, that is interaction force of 1 and 2, F13, 1 to 3, F1 to 4, like F1 to n, like interaction between each bodies to other each bodies. Both total sum is called a total force. It states that the resultant gravitational force F acting on a particle due to the number of points masses is equal to the vector sum of the forces exerted by the individual masses on the given particle. Now we can derive a Newton's law of gravitation from Kepler's law. Suppose the test mass is revolving around a source mass in a nearly circular orbit, radius of r. That means here mass is there, here then test mass, between them is r. Here this big mass is m and small mass is m. Suppose a test mass is revolving around a source mass in a nearly circular orbit of radius r with a constant angular speed omega. The centripetal force, we know that the acting on the test mass for its circular motion is F equal to mr omega. Here F equal to mv, because velocity is r omega, that is mv. M into r omega is mv, is the force, which is equal to mr. Omega is 2 pi by t, this time period of revolution. Then according to Kepler's third law, t is proportional to distance between them. That is time is directly proportional, revolving time is directly proportional to the radius. Using this in force equation, we get F equal 4 pi mr by kr, where k is 4 pi squared by gm, by using the constant 4 pi squared gm. Then applying this k values here, then F we can derive g into m by r squared. Which is a Newton's equation of gravitation. That means we got a Newton's gravitational equation, F equal to g into m over r squared, by using Kepler's third law. So far we have done is we explained about gravitation, gravitational force, Newton's law of gravitation, and its dimension of the value of dimensional value of g, that is universal gravitational force. And here this is a pictorial view, very nice picture to understand the force of attraction between the two masses. Principle of superposition of gravitational forces, and derivation of simple derivation of Newton's law of gravitation from Kepler's law. We have done. Please subscribe our YouTube channel.